Okay, so I'm going to do this example here. Has modern technology changed the distribution of birthdays? With more babies being born or being delivered by planned C-section, a statistics class hypothesized that day of the week distribution for births would be different for people born after 1993 compared to people before 1980. To investigate, they selected a random sample of people from both age categories, and recorded the day of the week on which they were born. The results are shown in the table. Is there convincing evidence that the distribution of birthdays has changed? All right, so the first thing we want to do here is calculate the conditional distribution in proportions of the birthday for older and younger people. So we did this way back in chapter 5. 5.3 is conditional probability. So we can do the conditional if we want to see like what proportion of people born before 1980 were born on a Sunday from this group. And so when I do that, I'm going to do, let's see. I'm just going to try and build myself a little table here. So these will be my conditional probabilities for before 1980 and after 93. Okay, so to figure out what to put here, I'm going to divide 12 by the total in that category, which was 77. And I'm going to write these as decimals, I think. So 0.156, I don't know. I guess I'll just write them as, how do I want to do this? No, I want to write them as decimals. 0.16, I think, is fine. So the next one will also be the same, since that one's 12 also. Wednesday also. Okay. Then I need to do 14 divided by 77.18. Thursday. Friday. I would do 9 divided by 77.12. And Saturday, .14. Okay, and then same thing for the other group. So 9 divided by, there's 73 in that group. 0.12. 0.15. 0.14. I hope y'all are checking all these numbers at home and letting me know if they're right or wrong. If you find something wrong, leave it in the comments. Thanks. Anyways, if we were in class, actually, I would probably be asking if you understood why I chose to divide by these totals rather than these. And the answer that I would hope that you would give is that I don't really care out of the people in the two groups what proportion of those were born on Sunday. Like, what the proportion of people born before 1980 versus after 1993 was on a specific day of the week. I want to know total what was the proportion of people that were born on that day for that age group. So if I wanted to make a graph comparing the distributions, I might do like a split bar graph. There are a few different ways that we could do this, really, but that's what I'm going to choose to do. Because, you know, with categorical data, a bar graph is usually going to be your best bet. It's easier to measure than a pie chart, and those are the two main ones to do categorical data. And so, let me see. On the bottom, I'm just going to put my days. So Monday, this will be Monday. I'll put Tuesday over here. Wednesday. Thursday. Oh shoot, I meant to start with Sunday. I'm just going to move my axis. Just because the chart starts with Sunday, so. Okay. Up this side, I'm going to do, let's see, we need, our smallest one is 0.08. And our biggest one is 0.18. I'm just going to go by 0.01. I went up to 20, which would be 0.2. I'm only going to need to use up until this one because that's 0.18. So this would be 0.1. Oh wait, that's not what I want. I want that to be 0.01. Oops. 0.01. Sorry. 0.05. This one's 0.1. Okay. This one will be 0.18, and that one we need, so. All right. Sorry, it's not the best bar graph ever, but you get the idea. So I'm just gonna put over here that black will be born before 1980, and I'll just use red since it's right here. And these are for each day of the week. I don't know how to write this, sorry. Okay, hopefully that's enough. All right, so for Sunday, before 80, we had 0.16. So I'm just gonna do, see, 0.16 would be here. And I'll just shade that. I'm gonna label above it just because it's kind of hard to see. So then for Monday, I would do also 0.16. For Tuesday, 0.18. Let me see, for Wednesday, we did 0.16 again. Obviously, if you wanted to make a really good graph, you would spend more time on it than this and probably use a pencil. Maybe some graph paper would be a good idea. 0.09. And for Saturday, 0.14. And then for after 93, let's see, that's 0.12. Over here on Monday, 0.15. Tuesday, 0.15 also. Wednesday, 0.14. Thursday, 0.23. Oh no, I didn't notice that whenever I was making the scale. Why didn't any of you tell me? I'm just kidding. Sorry. That one will be 0.23. .12. Those are the same. And 0.08. Okay. That looks like 0.08. Okay. So comparing these distributions, it does look like it's really hard to write a comparison for the distributions when it's categorical, so you have to be careful about the way that you write it. What we can say though is that there are larger differences, or where we see the largest differences in our data, and we can say like where it looks like it changes, because you can see, man, if these were drawn better you could really see it, but if you kind of trace where these black bars are, you can see that they're kind of just like all over the place. There's a little less variability in the black, like these two are the same, this one's just barely bigger, that one's the same as the first two again, like this one's a little low, but then we got these again, right? And so I don't know, they look a little bit more uniform. It's not perfectly uniform, whereas we have lower proportions with the red over the weekend, and then a big spike on Thursday, and then lower again as we get back to the weekend again. And so that seems, based on just looking at it, to support the claim of this statistics class. So if you kind of look at the way that they're set up, let's see, so I can say, like this actually should be a little higher. I should have used graph paper, sorry guys. Right, so the rest of these are fairly close. Like Tuesday's a little bit higher, I don't know, Friday and Saturday are a little bit lower. Thursday's the only one that's really a clear departure from the pattern here. All right, so hopefully that makes enough sense. You can see I have a note here that this would be a good time to pause and work on checkpoint number 1. I realize I didn't give you the checkpoints paper. However, these are the check your understandings that are in your textbook. So feel free to do that now. You should have some time in class to do it on Tuesday, but that time can also be used to work on homework, classwork, anything else that is assigned. So it'd be great if you went ahead and got ahead of those. Maybe leave a note in the comments if you did do it out of the book, and then I won't make extra copies and we can save some paper. Okay. Let's see. So if we're actually going to work this problem that we just talked about, okay? So if we want to state the hypotheses here, our H null is going to be, sorry, in the first checkpoint, you're just doing like basically what we did here. That's why I said checkpoint 1 here. And then checkpoint 2 is a full one, like a test, similar to this. So that's why I say do checkpoint 2 after I do this part. And then I think that's where I'm going to stop for this video. I know I do have another one here before chi-squared test for independence. I just, I don't want to put too much on here. So our hypothesis here, though, is, let's see, we were talking about distributions of birthdays, right? So we would say there's no difference in the distribution of birthdays, like for different days of the week, or for proportions of the birthday, like day of the week, not birthday one word, right? For the people born before 1980 and people after 1993. I put it as 2 words again because we're talking about like the actual day of the week that they're born. So if birthdays for so HA, I mean, that's just that there is a difference. All right, conditions. Let's refer back to the problem. Selected a random sample of people from, okay, we'll just, from both age categories. Random sample of people from both categories. All right, so that condition has been met. The 10%, I mean, that one's pretty obvious. So more than 770 people born before 1980, more than 730 people born after 1993. Oh, dang it, I didn't mean to start a new one. This is the 10%. I couldn't